Alright, today we are going to be talking about definite integrals, and obviously definite integrals are different than indefinite integrals, more for the fact that they have an upper and lower limit of integration, and as like the basic formula of integral follows, the function is right here, and then you have your g of x for the antiderivative. And the main difference between definite and indefinite is that definite will give you a final value of like a number, but as an indefinite will give you more of an equation.
Okay. So what an integral is you will take your graph, and with our equation from right here, we see where we are going. So we're going from 4 to 10. So if we have this at 4, this at 10, your integral will be this area under the curve from the x-axis, and this is all positive value. So the first step to taking your definite integral and finding your value is to take the antiderivative of your function. So you will do x, and then 1 plus your already exponent, so 4, and then your coefficient, which is 1, over your new value, 4, and then you will do plus, and do the same for this. So we'll do x squared, and then 2 over 2 is 1, basically just the x squared. The second step is then finding your values. So you're going to draw this line, which is evaluate from, and then use your same values you have here from 4 to 10. And then what you do is you take this, and for your x you plug in 4, and then you plug in 10. So it'll look like this. Evaluate with plugging in with the x values starting with 10, and then minus that, plugging in the x values of 4. So it will look like this. Minus this whole thing by the same, but plugging in 4 for your x value. And by this time you lose your dx. Alright, and then when you plug this all into your calculator, or you do it by hand and use correct parentheses, you will get a total number 2,520 for your answer.
So some definite integrals are a lot more challenging than the ones we've already seen. For instance, this one, which has a function of sine of 2x over 3x squared. So in this case, we are able to use a calculator, and it is definite because we have our bounds. First, we can start off by just using our calculator, just look at the graph to get the idea of what the graph actually looks like. So if we look at it now, it's right there. So if our bounds are -5 to 3, we can look and see that -5 is over here, and then we can look over there to 3, and most likely we can guess that our value will end up being negative. So to use your calculator for these problems, you're going to go to math, which is right here, and then we are going to go to number 9, so we can click 9 from here, and it should give you what an integral will look like with bounds, a definite integral, right away. So then we're just going to plug in the values we have for our problem. So we had -5 to 3, and then using the correct parentheses, we're going to add the sine 2x over 3x squared, and then we add our dx, and if we press enter, we will get our final value.
Alright, so our ultimate goal is to find the graph of cosine of x dx, and we are trying to find from 0 to 3 pi over 2. So as you see, this graph, it starts positive and then goes negative. And how to do that is we are going to have to do two different integrals. We'll do a positive, and then we'll do our negative, and we'll add them together to get the total area. So we are starting with our positive half. So at pi over 2, we know it changes to negative, so that's what we will do. We will do 0 to -2, the positive part, and we will take the integral, which will then be sine of x. So we will plug that in and evaluate from 0 to pi over 2. We will do sine pi over 2 minus sine of 0. When evaluating, we will find out that this is equal to 1 and sine of 0 is equal to 0, so we will have a total of 1 for a positive half. When evaluating, we will find out that this is equal to 1 and sine of 0 is equal to 0, so we will have a total of 1 for a positive half. Alright, we will now be starting with our negative portion. So that is from pi over 2 all the way to 3 pi over 2. So we will again evaluate. We will be sine x, just the integral, from pi over 2 to 3 pi over 2. And when you evaluate, you get sine 3 pi over 2 minus sine of pi over 2. And we can evaluate to figure out that it will be negative 1 minus 1 to equal a total of negative 2 for our
Alright, so now that we've found both the values for this integral as well as this, we can add both the values to get the total value of this integral. So we know that this value is equal to 1, and then we just add that to this value, which is a negative 2, making this all a subtraction sign. So this total value is going to be a negative 1, and that will be our final value for this integral.
Hello class, thank you for watching our video.
We hope that you've learned enough about definite integrals. Goodbye now.